Let's look at OpenStax College Physics, Chapter 22, Problem 20. A mass spectrometer is being used to separate common oxygen-16 from the much rarer oxygen-18 taken from a sample of old glacial ice. The relative abundance of these oxygen isotopes is related to climatic temperature at the time the ice was deposited. The ratio of the masses of these two ions is 16 to 18. The mass of oxygen-16 is 2.66 times 10 to the negative 26 kilograms, and they are singly charged and travel at 5 times 10 to the 6 meters per second in a 1.2 Tesla magnetic field. What is the separation between their paths when they hit a target after traveling a semicircle? So let's write down the things that we know. We know that the ratio of the mass of oxygen-16 divided by oxygen-18 is 16 divided by 18. And we know that the mass of oxygen-16 is 2.66 times 10 to the negative 26 kilograms. We know that they are singly charged, so their charge is the elementary charge, or 1.6 times 10 to the negative 19th coulombs. We know that they both travel with the same speed of 5.00 times 10 to the 6th meters per second. And the magnetic field that they're in is 1.20 Tesla. And what we're looking for is their separation between the paths after traveling a semicircle. So let's say that we're looking for some distance x. So here I already drew a diagram. Here we have one of the oxygens traveling on this semicircular path and the other one traveling on this semicircular path. And the question asks us what this distance is when they have traveled the semicircle. So let's look at one of these. I'm going to just look at, I guess, we're starting with velocity v. And the particle will travel and it will experience a force by the right-hand rule. If I place my hand in the direction of the velocity, so parallel to the velocity, and then bend my fingers out of the page, then it will experience a force in this direction. So I chose a positive particle and a magnetic field coming out of the page. We're not told either the direction of the magnetic field or whether the charges are positive or negative, but they both experience the same type of magnetic field and they have the same charge, so the forces will be in the same direction. So they could have bent down or they could have bent up. It doesn't really matter. So since the particle is deflected towards the center of this circle, this is the direction of the force, a combination of the tangential velocity and the force will deflect the velocity so that it will still stay tangential to the path and it doesn't change the magnitude, so that the force at this point will be in this direction. So the velocity is going to be deflected again in this direction. So the force at that location will be this way. So we notice that due to the magnetic force that acts on the charge, the particle will attain a circular path. So when we know that whenever sum of the forces results in a circular path, there is a centripetal acceleration towards the center of the circle. So when we're writing Newton's second law, the sum of the forces equals ma becomes sum of the forces equals mass times centripetal acceleration. So let's do that. Newton's second law. Sum of the forces acting on one of these charges is ma, and that a is the centripetal acceleration. Now, the force is the magnetic force, so that's charge times VB sine 90, magnetic field and velocity are perpendicular to one another, is equal to mv squared over r. So I'm going to divide through by V and solve for the radius. So the radius will be mv divided by qb. And this is true for both oxygen 16 and oxygen 18. So I will say the radius of oxygen 16 is m16v over qb, and radius of oxygen 18 is m18v divided by qb. What we're looking for is this distance, and this distance is actually twice the radius or the diameter minus this diameter. So twice the radius minus twice the radius. So let's write that down. X will be 2 times R18 minus R16. So I'm going to factor out a whole bunch of things here. This is 2 times V over QB, M18 minus M16. But I know from here that M18 is 18 M16 over 16. So this will be 2V divided by QB times, so M18 is 18 over 16 M16 minus M16. So I can factor out that M16. So X will be 2V divided by QB M16 times 18 over 16 minus 1. So let's plug in numbers. That will be 2 times velocity is 5 times 10 to the 6th meters per second. M16 is 2.66 times 10 to the negative 26th kilograms divided by 1.6 times 10 to the negative 19th coulombs, and magnetic field is 1.2 Tesla times 2 divided by 16, and that will be 0.173 meters. So oxygen 18 will have a larger radius than oxygen 16, and the difference between the places where they hit this location is going to be 0.173 meters.